Okay, picture this. You've just poured millions into designing and building this amazing, state-of-the-art industrial plant. The ribbon's been cut, the machines are all humming, but now the real question hits you. What's it actually going to cost to run this place, day in and day out? Well, today, we're going to pull back the curtain on one of the most critical numbers in all of engineering and finance, OPEX, or operating expenditure.
So here's how we're going to tackle this. First, we'll cover the basics. What is OPEX? Then we'll break it down into all its little pieces. After that, and this is the really cool part, I'm going to show you a powerful formula that gives you a solid estimate fast. We'll even test it out on a real-world jet fuel plant. And to wrap things up, we'll get into some pro tips on where to find your numbers and how to make them look good.
All right, so first things first, what exactly is OPEX? Think of it this way. It's every single dollar you have to spend just to keep the lights on and the products flowing after the whole construction phase is over. It's the living, breathing, ongoing cost of just doing business. The best way to get your head around this is to think about owning a car. Your CapEx, or capital expenditure, that's the sticker price. It's that big, one-time payment you make to buy the car. But your OPEX, that's everything else. It's the gas, the insurance, the oil changes, and yeah, those lovely surprise repairs that always pop up. It's the cost that just keeps on coming.
But here's the thing. OPEX isn't just one giant, scary number. Not at all. It's actually made up of a bunch of different costs, and if we really want to get a handle on it, we've got to break it down into its building blocks.
Okay, so here are the heavy hitters, the major pieces of the OPEX puzzle. You've got your raw materials, the actual stuff you're turning into product. Then there are the utilities, the steam, the electricity that keeps the machines running. But it doesn't stop there. You've also got maintenance, dealing with waste or effluent, and of course paying the awesome people who actually operate and supervise the plant. And finally, all those general costs like insurance and patents.
Now, what we can do is sort all of those costs into two main buckets, which makes things a lot clearer. On one side, you've got your variable costs. These go up and down depending on how much you're producing. And on the other side, you have your fixed costs. These are the ones you're stuck with no matter what. Let me put it this way. Let's say you shut the plant down for a week. Your bill for raw materials? It's going to drop to zero. That's a classic variable cost. But you still have to pay your salaried employees, right? And your insurance premium is still due. That's a fixed cost. Getting this difference is, and I mean this, absolutely crucial for any kind of financial planning.
Okay, now for the part I am really excited to show you. How in the world do we estimate the total OPEX without getting lost in a black hole of spreadsheets for months? Well, it turns out there's a brilliant formula for this. It's like an engineer's secret weapon, a shortcut that gives you a surprisingly solid estimate.
And here it is. This is Turton's formula. Now I know, it might look a little intense at first glance, but stick with me. It's based on data from tons of real-world plants, and it's actually super logical once you see what each piece does. So let's break it down.
So let's decode this thing. That first chunk, that handles your big variable costs, materials, utilities, and tacks on a little multiplier. The second part zeroes in on your labor costs. But the last term, this is the really clever bit. It estimates all your other fixed costs, like maintenance, by just taking a slice, about 18% of your original CAPEX. How smart is that? It's a fantastic shortcut.
Okay, theory is one thing, but let's put this formula to the test, right? Let's see how it works in the real world. We're going to use it on a super interesting project, a plant that's designed to turn eucalyptus into jet fuel. Yeah, pretty cool.
So here's the setup. This plant chews through 83 tons of eucalyptus an hour. And we know the upfront build cost, the CapEx, was a cool $286 million. So our mission is to figure out what's the annual OPEX going to be.
All right, first step, we got to add up all those variable costs. So after doing the research, it turns out the eucalyptus is the big one, by far. We're talking over $48 million a year. Then you add in everything else, the ethanol, enzymes, natural gas, electricity, and our grand total for all the variable stuff comes out to $82 million a year.
And check this out. When you put it in a chart like this, the main story just jumps right out at you. The eucalyptus is almost 60% of the entire variable cost. If you're the plant manager and your boss says cut costs, you know exactly where to start looking. Even a tiny discount on that eucalyptus would make a massive difference.
Okay, time for the magic. Let's plug our numbers into Turton's formula. We've got our $82 million for the variable costs, we've got an estimated $6 million for labor, and we have that big CapEx number, $286 million. Now, we just let the math do its thing.
And boom, there it is. The estimated annual OPEX for this plant is $169 million. Think about that. In just a few minutes, we've taken a really complex industrial plant and boiled it down to one super powerful number. That's a number you can take to the bank, use for projections, and make some really big decisions with.
Okay, so we've covered the what, the why, and the how. But now let's get really practical. Where do you actually get these numbers? And once you have them, how do you present them so that they actually mean something to people?
Yeah, this is the million-dollar question, isn't it? That formula is amazing, but it's totally useless if you're feeding it garbage data. So, where on earth do you find reliable industrial-scale prices for things like raw materials and utilities? Well, here's a great little pro tip. You can use a country's foreign trade database, like Comexstat in Brazil. It's totally free, and it's pretty straightforward. You just hop on the site, pick whether you're looking at imports or exports, find the product you're interested in, and pull up the data. Then it's just a little bit of simple division. You take the total dollar value and divide it by the total kilograms. Bam, you've got a real-world market price per kilo.
Now, that's not the only place, of course. You've got paid services that give you super detailed reports, and there are other free resources like textbooks and university sites. But listen, here is the most important tip I can give you. Never, and I mean never, use the price you find in a lab chemical catalog. The price for a tiny bottle of super pure stuff has zero connection to the price of a whole tanker truck of the industrial grade. That is a classic rookie mistake.
And that brings us to this key idea. It's not just about getting the final number. It's about understanding the pieces. The real magic happens when you visualize the breakdown, because a good graph doesn't just show you data. It tells you a story and shows you what to do next.
Remember that donut chart from our jet fuel plant? It's a perfect example. It takes a boring table of numbers and instantly turns it into a strategy. Your eye goes straight to that huge slice for eucalyptus, and you know immediately that's the place to focus on for cost savings.
But what if you're not just looking at one plant? What if you're trying to decide between, say, 3 different technologies? Well, that's where a simple bar chart becomes your best friend. It gives you that clean, side-by-side comparison so you can see in a split second which one has the lowest running cost. And here, yeah, option 3 is the obvious choice.
So there you have it. We've gone from what OPEX even is, to a powerful formula to estimate it, and all the way to some real-world tips for finding data and showing it off. The tools are all here. They're in your hands now. So the only question left is, what's the biggest cost driver going to be in your next project?